Unit 2, Using Objects, Lesson 1, Creating and Storing Objects. The objectives of this lesson will be to explain the relationship between a class and an object. Identify using its signature the correct constructor that is being called. Create objects by calling constructors with and without parameters. And define variables of the correct type to represent reference data. Up to this point, everything we have written or explored has been in a single main method inside a single class. Public class example. Public static void main args system.out.println hello world. We know that in a Java program, the main method is the only part of the code that will run. In order to take full advantage of object-oriented programming, a Java program can be written in many different with many different methods and many different classes. Object-oriented programming is a style of programming where you declare classes, create objects from these classes, and write programs that have interacting objects. This programming paradigm puts data at the center of your program instead of logic. Everything you do in object-oriented programming is centered around data and how data interacts with each other. Data takes the form of objects. An object in Java is something we can use in code that has both a state and behaviors. If we have a dog class, think of it like a blueprint for creating a dog object. Any dog we create will have this state and these behaviors. The state might be different for each dog, but they will all have those attributes. The behavior might be the same for each dog, such as speak, or it might be different depending on the dog's state, like have birthday. So here, when we create a dog, it's going to have a name and an age, and the Boolean variable is going to say true if it's a good dog, false if it's a bad dog. The behaviors that we're going to have for our dog at first is speak and have birthday. Have birthday means that it gets a year older. Now, a class is a template for the object. It defines what data, instance variables, the object will have, as well as what its behavior will be. Below is the general template for an object creating a class. Public class, an object name. So public class dog. Then you're going to have your instance variables, your constructors, your accessors and mutators, toString and equals, and your behaviors. Right now, we will be discussing instance variables, constructors, and behavior. We will save the accessors, mutators, toString, and equals method for Unit 5. Remember, there are some things that you just have to take on faith until we get to it. Now, creating instance variables. Instance variables define the data that your object will be described with. Sometimes these are called fields. You want instance variables to be private. Okay? People shouldn't be able to change your name or your age. Only you can change your name or your age. This is a pillar of object-oriented programming. Encapsulation. This is protecting data from being manipulated by methods and classes that you don't want to change it. By setting the instance variables to private, you are saying that no other class besides the object creating the class can manipulate it. We can use instance variables freely in our object creating class. If other classes want to access the data, they will have to use the accessor methods that we're going to discuss in Unit 5. And sometimes other classes might be able to change your data, but again, that will be in mutators. Okay, so it's really going to be another class asking this class to change itself. So here we've got public class dog, and then the private data, the name, the age, the good dog. Instance variables are declared at the beginning of your object creating a class. All instance variables are private. Instance variables are just declared. They are not given values. The constructor or constructors will take care of those. You can have as many instance variables as you want. In order to create, or what we call in programming, instantiate an object, you have to construct the object. This is where our constructors come in. There are two different types of constructors, default and parameter. A default constructor happens when it is called upon. It will instantiate or create your object by providing space and memory for the instance variables and setting them equal to default values. If you don't know what anything is, you just use the defaults. You want this to be public because other classes will need to call upon it to create objects. You will not have the word static anymore. Static is used for methods not associated with an object. This one's associated with an object, so you don't use static. There will be no return value, not even void, on constructors. Constructors simply construct space and memory. They allocate memory. That's it. So we have public dog. You would give it a name of none. It's 0 years old, and we're going to say it's a good dog. The default's going to be good. Constructors must have the same name as the object class. So I can't name, if my class is dog, I can't make my constructor something besides dog. Okay? A default constructor has no parameters, which is why the parentheses are empty. Right here, see? Empty parentheses. The instance variables have already been declared outside the constructor. So inside the constructor, they are all set to default values. Within your class, you already have name, string, name. So the computer knows it's going to be a string. Age is an int, and good dog is a Boolean. So you're not declaring them here, you're simply initializing them. Remember that the class created space, did not give it a value. You as the programmer can decide what the default values are. For any class, there is one and only one default constructor. The other type of constructor is called a parameter constructor. And in your class, you might have no parameter constructors, or you could have as many as you want. You need to have a default constructor, however. Java will automatically create one if we don't have it. But it's not very good programming style. It's really good programming style to always include the defaults. Now, the default is just if somebody creates a dog, it sets that all up. But let's say somebody wants to create a dog and they already have a name and an age. Well, then you can use a parameter constructor. This constructor will serve the same purpose as the default constructor, except here you're going to pass it parameters to set the instance variables to. You will use this constructor when you have data that you want to create with your object. So if I know the name and the age and whether or not it's a good dog, I'm working at a shelter. I can create dog and I can actually give it a name and age and a true or a false for being a good dog or a bad dog. Inside the parentheses of the constructors are parameters. There are 3 parameters for this constructor. I don't have to know all of them. I could have a different number of parameters and default the others. Like if I didn't know if it was a good dog, I could just have 2 parameters and then set good dog to a default. Now, a parameter should start with the data type of the variable, followed by the name. You want to avoid having a variable name that matches the name of the instance variables. While it is allowed, you will have to use this keyword that we will discuss later, but it can be confusing. So for now, don't name them the same. Notice name and N, age and A, good dog and G. The parameter names are not the same as the instance names. Parameters are separated by a comma and can be in any order. You could also have written int A, Boolean G, string N. When we create an object, we will pass it some data values, a string first, an int second, and a Boolean last, and that becomes the data for our object. When we call this constructor, our call must put the values in the correct order because it's going to pass it in that order. But when I create or you create the constructor, you can pick the order that you want them. Now, as stated on the last page, you can have none, one, or many parameter constructors. It just depends on what type of data you will have when you create your object. Here are some examples of other parameter constructors. In this first one here, public dog, string in, int A. This would be an example of when I only know the name and the age of the dog, but I don't know yet whether it's good dog or bad dog. So I'm going to select true. I'm going to default to true. All right. I could also have something where I know that a dog's good or bad, so I can pass it that, but I don't know its name, and I don't know its age, so I'm going to default those. The last thing we're going to look at in our object classes for now is our behaviors. We had two behaviors we wanted our dogs to have: speak and have birthday. Creating behaviors. Any behaviors we want our objects to have are created using methods. This is like a function or a procedure. Methods can either be public or private. For our objects, we want them to be public so that other outside classes can use them. Methods can be static if they do not interact with an object. For us right now, our methods will be working with our dog objects. So this keyword will not be included in our method header. We will see static methods in Unit 5. Methods have a return type. If they return no data, we call them void. If they do return data, like an int or a string, we have to list the data type. We have to list the data type and are part of our method header. Method names usually begin, I don't know why it says begin with a lowercase letter and follow camel case after that. They typically sound like an action, but this is not required. Okay? But remember, methods are behaviors, so typically it's going to sound like a verb. Methods may have no parameters or many. Parameters allow you to pass data for the method to act upon. Since the methods we are creating now are located in our object class, we do not have to pass it our instance variables. Here are two methods in our dog class. Public void speak, system.out.println, woof woof. Public void have birthday, age plus plus. Our speak method does not interact with our instance variables. It simply outputs a line, woof woof. Our have birthday, that one will increase the age of whatever the object is being called by 1. So if it's Rover.have birthday, Rover's going to become a year older. Now, our complete class, here it is. This class is actually included in your notes, so you can look at it closely. But notice, public class dog, private string name, private int age, private boolean good dog. Those are our instance variables. Then we have our constructors. The first constructor here is our default constructor. Next up is the constructor if we know the name, the age, and the temperament. The next constructor is if we only know the name and the age, and we're going to default. Okay, it's not a default constructor, but we're going to set the default value for its temperament. Then we have speak, public void speak, and it's just our woof woof. And the have birthday just increments the age. This is a complete dog class. If we want to create a dog, all objects are stored using reference memory. So when they're created, they point to a location in memory that contains the state or instance variables as well as their values. If an object is declared but not instantiated, then it's null. It says, hey, I know I'm going to have this dog named Blue, but I'm not going to create it yet. I just know it's going to be there. Okay? Once an object is created, that reference variable is used when it needs to call on any method from the object class. Creating objects takes place outside of the object class, usually in a main method or in a main method of another class. All objects are created with the new keyword. The new word gets put right in front of the constructor call. So you would say new dog and then instantiated. Let's take a look. Dog, Mila. The Mila object would have a null reference because it hasn't actually been created. Okay, we're just saying I'm going to someplace down the line create my new dog. So that's just declaring it. Instantiating an object with the default constructor would say Mila is set to new dog. The default constructor is used. So here I declared it, here I instantiated it. Now down here, if I want to instantiate it and declare it at the same time, I would say dog buddy is set to new dog. And then here I'm using the parameter constructor and I'm passing it the name, the age, and the temperament. I also have our dog Queenie, and I'm going to declare Queenie as dog Q, and I'm going to use the parameter constructor that just knows the name and the age, but not the temperament. And in memory, here's what happens. Okay, if I don't instantiate it, I just get Mila, and it's waiting to be created. Once Mila gets created using the new dog, it sets up memory, and in this case, that was the default constructor. Down here, you can see what happens with Buddy and Queenie. Now that we have 3 dog objects, let's see how we can use those methods we created. We're going to trace the lines of code below to determine what they do. Mila.HaveBirthday. Mila is our calling object, so her age would become 1 according to the HaveBirthday code. Because remember, she was instantiated with his age of 0. Buddy.Speak. Buddy is our calling object, and woof woof would print. Q.HaveBirthday. Q is our calling object, so the object's age would change from 10 to 11. This first part tells us which dog, and then this is our action. That ends lesson 1.